So class, today we're going to link back into what we've been doing so far with food webs. Remember in the past couple classes, we've been going through and we watched the Magic School Bus video about how food webs worked. We did our big food web activity. You guys were all hooked together to see what happens when one section of the food web disappears. And you guys already have the papers for this. Those are the Ecosystem in a Jar Lab papers you have in front of you. And basically what we're doing today is we're actually going to build a small-scale ecosystem that you guys are going to observe. And you're also going to be doing a little bit with a change in how, changing something about it, see what happens, and compare with other people because each one of you is going to kind of choose a little bit different thing to do with this. So, basically our central question today is how does energy and matter travel through an ecosystem? That basically says how does food travel through an ecosystem? And also how do other things that we're going to look at later in this section with water and air and things like that, all related to this. So, our learning objectives today, we're going to observe a working ecosystem, we're going to develop and test a hypothesis about your ecosystem, and then we're also going to build and analyze the working components of an ecosystem. So, to start with, I'm going to give you guys a couple of minutes to do this. This is your warm-up. It's already on the paper I put up here. Facing the box on the worksheet, I want you to talk with your partner or partners and go over basically what things do you think that a living thing needs to survive. We talked about these before, right at the start of the year. I just wanted to go back through because these are the things that your ecosystem in a jar are going to need to survive. So talk about this with your partner, have one person in the group write it all down, and I'll be calling on groups in about 2 minutes.
Everybody gets a bottle.
Not everybody's groups.
Like groups, I mean, and then we can keep the pace.
We'll see.
We'll see.
See how it works.
Think about it. No, you put it on.
Yeah. Talk about what is living.
So we get everything.
Yeah, so no, you don't have to write down what's on there. You just have to write down what things do living things need to survive. What do they need? What do you need to survive? Not that different.
Excuse the interruption. Student retakes for the following homerooms may report to the auditorium now. Ms. Carter, Ms. Kemmerly, Ms. Lawless, and Mr. Girardi.
Okay. So I see pretty much everybody's been getting to work on this. But basically, so what exactly are you? What do animals, plants, what do they all need to live?
Food, water, and food.
Food, water, plants. What did you guys get? Turtle? Okay. Daniel, what did you? Hiding spots? You guys had? Food, water, and shelter. Okay. Food, water, shelter are great. Other animals are great too. Food, what's that?
What about trees?
Trees, yes, trees are great hiding spots. They're great shelter. They're great food. Hey, there's one big one that you guys are kind of forgetting we have to make sure is in our jar too. And that's what we're doing constantly whenever think about it. It's air. And actually our little systems here, when we build them, they'll crash if you don't have enough air. If you just completely fill them with water and seal the jar at the top, they won't survive well. They need air. And basically these little jars are going to be like little Earths. We're in a sealed little jar of our own. Nothing comes in our atmosphere really, and not much comes out. We're in a sealed little area, and everything that we have here all interacts. So that's what we have to get into for this activity. So, what we're going to do, and basically we're looking at what an ecosystem in jar is. So what we're going to do is we're going to be building one of these. And what it is, this is a sealed ecosystem, meaning once we put the living things in here, some water, some gravel, plants, fish, snails, once all those things go in, we're going to seal this up.
Snails grow
With no air?
The air is going to be inside. We're not going to feed them
Why?
because we're going to seal an ecosystem.
So
Because nothing from outside our world is dropping off food to us.
So they're gonna die.
If everything goes right, they will not die. Because inside of this jar, okay, can then eat the plants for their food systems. There's also little plants, remember from the Magic School Bus video, the ecosystem of the beach with a pond stump. Those little algae pieces are food for the fish too. There's also some good stuff like bacteria in here, so there's food. There's going to be water, there's going to be air, there's going to be sunlight to help the plant make food, and there's going to be living things. And they have shelter. So basically the idea is they have everything they need in this jar, and that's the idea of an ecosystem in a jar. And some of these, we're going to seal ours for 2 weeks. There's one of these operating at my high school right now, which was started when I was in high school, and it's still living. And that puts it at, I believe, 14 years old now, and it's still operating. And he goes one of these jars. A little bit bigger jar. We didn't put any fish in that one, but it should be able to sustain pretty well. So, what we're going to do is, I'm going to get each group a jar to start off with.
Well, are these clean or something?
I did scrub them out this morning. So each group a jar. Now, we're going to put a little bit of gravel in each one of these. Now, what the gravel does, the gravel provides you a lot of stuff going on in there. It gives you a place for the algae. It gives you a place with, gives some bacteria in there. And this gravel came from the bottom of one of the aquariums in my classroom. If you ever want to build an aquarium, they always tell you to use what they call activated gravel to start. And what that is, it's gravel that originally came from another aquarium because there's good living things in there. So, you guys out with this? Basically, we're going to get the gravel and we're going to get the plants. So, gravel in each one. It's just something after the
So you recording this?
You guys need it's about 2 inches of gravel on the bottom.
So you recording this?
Yes. The gravel is going to give us all those little things you can't see that are living down there. It also works like soil. It gives the plant a place to set its roots. Out. Okay. So guys, now you have your gravel. Didn't work that time, sorry. So now real quick before I have the plants, I forgot to put this stuff on the projector. I'm going to give each group a little bit of water, just to start off with for the fish, or not for the fish, but for the plants. Just a little bit to get them started. These are aquatic plants. They spend their entire lives in aquariums. I got all this last night at PetSmart. So if you guys ever want to try this on your own, you want to build your own little aquarium. These living plants can do a lot of good. They're better than the, if you can manage for them, they're better than the plastic ones.
So we put the fish in there?
Now, and guys, you will be getting more water than this. I'll actually be setting I'm not going to give you guys all your water today because I need to make sure that the atmosphere levels are as best as they can be so we give them the best shot of survival. I've done experiments with that before with my EP level students, and it gets a little bit difficult to make sure that part, so I'll handle that. But, so I'm going to give each group, I think I can give you guys 2 pieces of plant, which is better than 1 because you get more food. And guys, this plant is called a Nacarus, which is just an aquatic aquarium plant. One environmental thing though, if you ever have an aquarium that you don't want the plants in it anymore, you don't want the animals in it anymore, don't ever dump it outside. Don't ever dump it in a ditch, don't ever dump it in a stream, a pond, anything like that. Because these types of plants, normally they come from like South America. They do really, really well in our ponds and streams, but that's a bad thing because they make all the stuff that normally lives here go away. So what I need you guys to do with this, and you may want to utilize a pencil or something like that, where you can get your hand inside without getting it stuck, is to push the base of the plants down into the gravel. You can see on the base of the plants, there's some roots. The part that I hope you guys get gravel, the part that's in your fingers goes down first. So it's going on the gravel, and the whole plant goes down. Yeah, try to push these parts down into the gravel the best you can.
Like that? Like that?
Yep. Push that base down the gravel as best you can. So these groups are going to get 2 plants. Let me make my own one of these too. Push it down into the gravel before we get the fish and everything in. And guys, then the whole plant goes inside. It doesn't lean out or anything like that. Okay.
How are you? Take your pencil. No, I don't even know.
Hey guys, as long as those roots are down near the gravel, they should be fine. You just don't want them floating on the surface. We'll be careful with the water. The worst thing you do is stir it up when you pour the rest of the water in. Now, here comes a little more of a part where you guys have to put some thought into it. I think everybody has their plants in. What we're looking at is, you guys are going to be forming a hypothesis. How many of you guys have heard that word before?
Me.
In science, hypothesis. Okay. Hypothesis, does anything tell me what hypothesis is?
It's about
Making guesses. Okay, that's great. Making guesses, seeing what you're actually, trying to predict what happens, trying to predict something that if you change something, what will happen? And we are changing something in this. I'm going to allow every group to kind of choose their amount of fish that goes in here. Now with these, okay, now with the fish, and part of forming a hypothesis is knowing a little bit of background. What I want you guys to think about is how much space you have right here, and how many fish you think it actually can support. So, I'm going to let you guys choose from between 0 to 3 fish. And on your group's paper, I want you to talk about this as a group, come up with a number, and I'll get you guys your fish. As you're talking about it, I'm going to go ahead and put a snail in there. So, we're going to go ahead and put the snails in there. The snails serve another role, but the fish. So I want you guys as a group to decide. Okay, as a group, I want you to decide basically how many fish you want to go into your system. 0 to 3. Don't say 12. They won't like it. You would like being put in there with 12 things.
put 2 in there.
Building
That's what you're doing.
environment.
Hey, and guys, where you write this down is on the back of your paper. Yeah, it says right at the top, it says, the ecosystem will perform best with blank fish. Write in your number.
Oh, we haven't picked yet.
Come around and deliver your snail. If someone wants to put it in, just be careful with them. Don't drop them from 10 feet off the ground. It won't work well.
Do them move?
Not really, they want to keep back in the water. Guys, these are aquatic snails, they can't be out for too long. Do you guys want to put them in, make sure not to get them with a few.
Here, why don't you work with Bryce?
Can I drop it?
They're building a whole
It has to be in water.
Chair right here. Yeah, there's one right behind you.
I'm just going to put the chair over to the side. I have the camera going. Oh. Actually.
We can put it over there.
So, now we'll get the snail in there. Okay, we have 3, we have 2, 1 fish. How many, Bryce, okay, how many fish are you going to put in there? I said 0 to 3. 3? Okay. So we have 1, 2, and 3. Okay, that's great. I'm glad you guys chose some different numbers and everybody chooses the maximum. It makes it really hard to compare. Yes, it is. It is alive.
Is that moving? It will.
It's alive.
Leave it alone. Yeah,
Okay, so guys, I'm going to come around with the fish now that you made your selections. Okay, 2. We have 2 and 3. I'll get you another one in a second, Dave. There'll be more water. Finish on this tip. And guys, I'll get you some more water in 1 second. I know they're kind of pink, but it's a little bit different water than what you're used to. You're not keeping the same tank.
Yeah, I missed that part.
Yes.
Oh no, I banned my.
Okay. So guys, now you have a hypothesis. You think that your system's going to work best with 3 fish or 2 fish. Now, no one chose 1, no one chose 0, so we don't have. I will make those up so we have a comparison. But in reality, we're running an experiment. We're going to see how these ecosystems work based upon how many of these big-time consumers. Remember, consumers eat everything. So these fish are consumers. They are going to be consuming things in our ecosystem. They might be, so we're going to see which one of these types of systems works best. I have some extra. I think I can make 2 more. I'll make 0 and 1. Now, the one thing is my upperclassmen, they are doing this too. My AP, like they're my level 3 AP level students are doing this. However, they went back and they captured theirs, which is actually it's harder, especially since we're doing it twice. Their first time, like they're putting in things that really shouldn't be there. I actually had to dump out through them yesterday. They put crayfish inside, and in one of them they put like 4 minnows they caught out in the stream, and then put a crayfish in. The crayfish ate 2 of the minnows already, so there's remnants of minnows in it, and that's not going to be good. They're basically trapping your system now. Little job. Okay. So guys, in here, remember you have all 3 parts. Do you guys remember the 3 main types of things in the food web? What are the 3 types of animals you have in the food web? Or animals, plants, things like that? Yes. Oh yeah, the grasshopper was definitely in there. But remember, they come down to what they do. We have our producers, which are animals that produce.
Okay, I'll be right back.
We have our consumers, which consume and eat. So producers make the food. Consumers consumers consume all the food, and then you have your decomposers. You guys do have decomposers in the system already too. That's why the snail is there. The snail is there to basically eat any waste.
Do we not have a white piece?
He's there to, he also eats some of the plants too, but mainly he's our decomposer. And that gravel also has producers and decomposers because it has algae, which shows like the phytoplankton in the video, they make food. And then your,
Mr. Hodge, so we get an illustration from?
so now, those fish are gonna live a life in one of my aquariums right now. Make sure everybody's about the same level. But I'm going now. Today we only have like 1 or 2 more minutes. But next class, so we only have 1 or 2 more minutes. There is a summary for this that I would like you guys to do. Since I have to head out, but hopefully you guys can do this. What I want you to do is for your summary, you're gonna on the back of this sheet. I want you as a group, someone in the group, where you guys work together to draw the eco jar with everything that's in there, and try to make a food web of all the things that are living inside. So you're gonna draw the jar, draw everything that's in it, and then try to diagram out a food web of what's eating what, where everything connects. So what's making the food, what's eating the food. And one thing is actually, Scurzy asked if I could, I'm going to take these back out for today. I'm going to seal them so that they are not,
Take these?
yeah, I'm going to take them out, and I'm also, when I go out, I'm going to seal them, which means I'm going to put the lid on, we're going to put some parafilm, which is like kind of like a tape around the outside. It's going to keep all the air from getting in or out. And we're going to see how these work over the next 2 weeks. So the idea is the next class, we'll get to observe them, we'll get to see how they're doing, and we're going to do a little bit of journaling off of that too. And then hopefully at the end of 2 weeks, we'll be able to kind of come to some conclusions about how the ecosystem works best, how many fish it can support, things like that. So does anyone have any questions? Okay, so at this point, basically, if you can, just sketch what's in your ecosystem, in your eco jar, and try to draw out a food web or a food chain to go along and show everything that's there.
I can't draw a tree. I can't draw it.
Try.
Try. All you have to do is try.